Hello students, welcome to the Training Academy of Physical Science students. Today we are going to show you how to logically apply the basic equations of motion with constant acceleration. When an object moves with a constant acceleration, there are four equations which can describe the motion of the object. So I'm going to write it down. First one is V equals U plus AT and S equals UT plus half AT squared. Third one, V squared equal U squared plus 2AS. Fourth one and final one, S equal U plus B divided by 2 into T. So I'll denote the unknown terms here if you are not familiar with these equations. V denotes final velocity. U denotes initial velocity. A denotes the constant acceleration. Remember, it's constant, okay? Otherwise we can't apply to any of these equations. T is the time, as you all know, and S is the displacement. So going on to the first example, here final velocity is given as 20 ms minus 1. Initial velocity is also given. Acceleration, which is constant, is also given. And they are asking to find the time taken to reach the final velocity. So before you do it, first listen. Out of the four equations that we described before, using only one equation, we can directly reach the answer. What I want you to do now is pause the video and without looking at the four equations or writing anything, just think of the single correct equation out of the four needed to solve this question. Did you think of it? So the correct equation is V equals U plus AT. V is given, U, the initial velocity is given, A, the constant acceleration is given. So only unknown remaining is T, which the question is asking to find. So you can simply substitute and you will get the answer. Subtract 5 from both sides. We'll get 15. Yeah. First, I tried to improve your knowledge of application and logical thinking. Now I'll show you how to logically find the correct equation. Moving on to the next example. An object is thrown vertically upwards with a velocity of 50 ms minus 1. Find the displacement from the initial position after 2 seconds time from throwing. So first pause the video, as I said earlier, without writing anything, only by thinking, understand or find the equation necessary to solve this question. So how to solve this? First, always recognize the hidden data here. An object is thrown vertically upwards, which is very important. That means the object is under gravity. Gravity is constant. Therefore, the object is moving under constant acceleration or deceleration. Therefore, we can use our 4 equations here. Let's take G as 10 ms minus 2. So there is another factor we have to recognize. What are they asking about? What are they asking us to find? It's the displacement, right? So out of the 4 equations, V equals U plus AT, S equals UT plus half AT squared, E squared equal U squared plus 2S. Finally, S equals U plus V divided by 2. So they are asking for the displacement, which means this equation automatically cancels it. Since we have been given the initial velocity and the time, both these are available only in this equation. You can see time is not here. So the correct equation we have to use is S equal UT plus half AT squared. So this whole process has to be done by your memory. That's why I initially try to make you think of the correct equation used to understand. There's another thing that I need to explain you when applying the equation. You can see the terms are displacement, initial velocity, acceleration, and finally time. So here, except for the time, all are vectors, which means they have a direction. So we cannot neglect their direction at any particular period. So when we apply the equation, we have to always give a direction to the equation. So I'll explain it here. When the object is thrown upwards, there is an opposite side as well. So we can take positive as the direction of motion and the negative as the opposite side. I'm going to give a direction upwards here. So the object is thrown upwards. I'm going to apply the equation S equals UT plus half AT squared to upwards direction. So displacement we don't know. Initial velocity is in the direction upward, so it's a positive value. So it should be 50 minus 1 into t. T is a scalar, so you don't have to worry about its sign. Plus half, and here it's an important factor, acceleration. Where is the direction of acceleration? So gravity is always acting towards Earth, which means it's acting towards the floor. The object is moving to the opposite direction of the floor. So the object is moving in this direction, while gravity is acting in the opposite direction. So the acceleration should be negative. You understand? So we write minus 10 ms minus 2 here. I'm sorry, time is also given here. 2 seconds into 2 seconds square. I'll show it here in more clear manner. 50 ms minus 1 into 2 seconds plus half minus 10 ms minus 2 into 2s square. So you can see acceleration here is negative. So simplifying, we get 100 meters plus half to minus 10 into 4 meters. You can do the unit balance and find out it will come out as meters. 2 to 2 cancels off and 2 remain. This minus into plus becomes minus, therefore the answer is 100 meters minus 20 meters. Final answer therefore is 80 meters.
So that's it for today. The lesson we did today is simple, but the methods and thinking patterns we followed will be very important in solving complex problems in the future. Thank you. Stay with me for more new videos.